warming that we've seen so far and that's triggered the phenomenon that I've described. The climatologists are also in robust consensus. They're firmly convinced that if we're not able to make very, very quickly the transition off fossil fuel, if we're not able to stop burning coal and gas and oil with great speed, far more quickly than we're planning to at the moment, far more quickly than is politically or economically convenient, if we're not able to make that transition, then the temperature in the course of this century will rise 4 or 5 degrees, maybe more. That's not the worst case scenario, that's the absolute middle of the road prediction for what we're facing. If 1 degree is enough to melt the Arctic and add 5% more moisture to the atmosphere and kick off the kind of changes that I have described, the bottom line is we do not want to find out what 4 or 5 degrees looks like. There's no reason to think that we can sustain anything that resembles our civilization in the course, with a temperature rise of that size. And we could list for a very long time all the reasons that that's true, from rise in sea level to very, very basic things like the inability of our fundamental grain crops, corn and wheat and rice, to produce yields once the temperature rises to a certain point. We're already seeing rice yields depressed by high temperatures. The data from Stanford and the University of Washington in the last couple of years has indicated that if temperature increases on that 4 to 5 degree line, we'll see yields of corn and wheat fall 40 or 50% around the world. Clearly a completely impossible situation for a world that's already food stressed. So the bottom line of the science to me goes like this. 1, we need a very, very quick global transition off fossil fuel in order to arrest the rise in temperature as close to 2 degrees as we can get. 2, even if we're able to do that, we still have an awful lot of work cut out for us adapting to that rise in temperature. We're going to have to change an awful lot of the things we do, like the ways that we grow food, in order to deal with changes that we've already locked in, those rises in temperature, those changes in hydrology, changes in sea level, all of that. We're going to have lots of work to do to adapt. 3, if we can't make that transition off fossil fuel quickly, then the temperature will likely rise enough that effective adaptation becomes impossible. That is to say, you could build the most perfect local food system, all organic agriculture, everybody doing the right thing wherever you are. You could adapt Sigtuna or Stockholm or Vermont, where I live, or whatever, as perfectly as you possibly could imagine. But if the temperature goes up that much and it rains every day for 30 days, or it doesn't rain at all for 30 days, then you're not going to be able to grow anything. You're going beyond the boundaries of what is possible to adapt to if we do those things. So for me, that's the scientific bottom line, and it puts in place a set of parameters that have to do especially with speed that constrain our possible ways of reacting here. That is to say, any kind of remedy for the problem that we're facing that demands a long, slow, complete overhaul of our culture before we get around to dealing with carbon in the atmosphere probably is going to happen too slowly to be of scientific use at this point. It may well be that those cultural changes are very important to try and force as fast as we can and will go on long into the future as we adapt. And it's not at all that they're off the table. It's merely that having taken no action so far, we're now constrained to act more quickly than is desirable in any number of ways. And that's simply the bottom line. Let me make a similarly short and grim set of assumptions about the kind of values and ethical questions that this raises. The first thing that should be noted about these changes, of course, it's sort of obvious, but worth saying every once in a while, is that they are being carried out entirely by one species, ours, and imposed on every other species on the planet. Whatever benefit there is that's coming from all this burning coal and gas and oil is accrued entirely to one species, all the damage to all the other species. That raises significant ethical challenges. The second thing to be said is, among our species, it's only a very small percentage of people who are carrying out these changes on any scale that matters. And oddly and sadly, there's an almost inverse relationship between how much of the damage you cause and how quickly you're damaged by these changes. That is to say, the poorer you are and the less fossil fuel you're burning, the more likely at the moment you are to be affected quickly and dramatically. Another way of saying that is that peasant farmers along the Indus River in Pakistan had absolutely nothing to do with causing the problem that they face at the moment. Nor, since I just was looking at the paper this morning from India, nor did the slum dwellers of Lahore, who are now, just as we meet here today, facing a raging epidemic of dengue and filling every hospital in the city, a mosquito-borne disease that spread like wildfire in the last decade around Asia and South America because mosquitoes really like the warm, wet world we're building for them. Nor did the slum dwellers of Lahore have anything to do with causing the problem that's now literally killing them by the hour in their homes. Third ethical point, just always to bear in mind, even among that tiny percentage of humans who are causing this, not tiny, but 20 or 30% of the population who are causing this problem, it's always also worth remembering that these are only present-day humans who are causing this problem and benefiting from this burning of coal and gas and oil. And in so doing, they're constraining the future for every generation of our own species that will follow, permanently degrading the one planet that we have, and foreclosing possibility for people in the future. So I guess all I'm trying to say is the stakes are incredibly high, and there's no ethical system that I know of, no construct that allows us to behave as we're behaving, and yet we're doing it, and we're doing it without very much in the way of thought or reaction. Another way of saying it, perhaps, is that one of the things that always strikes me as very ironic about our situation is that the main opponents, at least in the United States, of action on climate change style themselves conservatives, call themselves conservatives, when in fact they're engaged, we all are engaged, in the most radical act that human beings have ever undertaken. Nothing that human beings have ever conceived of comes anywhere close to dramatically changing the gaseous composition of the atmosphere and just seeing what happens as a result. The incredible radicalism, the incredible recklessness and irresponsibility of that is so large that I think we tend not quite to think about it in those terms, almost defensively, because it's too big to sort of imagine the thing that we are doing and the way that we will be judged by history, should history be in a position to be offering judgments down the road. So, the question is, what are we going to do about it? What set of things, changes, can we make that will begin to rise to the scale of the problem that we now face? And that's where I want to talk, and where I promise to be a little more cheerful than I've been here before. Not right at the beginning. We'll still spend a little minute on the depressing political reality. The first thing to be said is, Well, the first things to acknowledge are, A, scientists have done their job and done it with remarkable skill and speed. In 20 or 25 years, we've isolated one of the most difficult problems in physics and chemistry that people have ever encountered, developed workable models that explain what's going on, reached a scientific consensus on causes, and given some sense of the magnitude of the cures that we would need. There's still interesting scientific work to be done, but for the most part, the physicists and the chemists have left us with more than enough, and they should be rightly proud of their work. And it is a great shame to watch the forces of the status quo try to embarrass and bedevil them, i.e. the bogus email scandal from the University of East Anglia last year, or whatever it is. 2, the engineers have, to a larger degree than we perhaps always give them credit for, done their job too. We really know many of the things that it would take to allow us to move much more rapidly than we're moving in the direction of a renewable energy future. Solar energy and wind energy, which 20 years ago were still somewhat science fiction projects, are now entirely real. In wind, you don't have to look very far around Scandinavia to see its potential. Wind is the fastest growing source of electric generation around the world, though the base from which it starts is so small that it still makes a fairly negligible contribution. Solar power is becoming by the month cheaper as we get better and better at producing solar panels and things. There are real possibilities here. We no longer have to sort of speak about it with our fingers crossed or, in an attitude of prayer. We now can, to some degree, count on those possibilities. The question is, will we be able to deploy this stuff fast enough to matter? Will we be able to make changes in our own lives in terms of conservation, efficiency, and change in habit? And will we be able to deploy this new technology fast enough to matter? And at heart, that's a question not of technology, but of political will. Will we decide as national communities and as a world community that this is something we're going to do, that we're going to force the pace, make this happen faster than it naturally would? Left to its own devices, 75 or 100 years from now, we'll all be using solar